Morning, guys. So today we are going to review each and every topic we did during this half of the semester. So if you remember, we started with standard deviation. So let me share the screen with you. Sorry. I hope all of you can see the screen right now. So yeah, like I said, we started with standard deviation. So why do we use standard deviation? Is to actually measure the spread of data. This we have already discussed. So there are other methods to measure the spread of data, which is range and interquartile range. This time, we are using a different parameter called standard deviation. Now, what is standard deviation and how to find standard deviation? That's what we are going to discuss. Okay. So standard deviation. And this is the formula for standard deviation. I want you to go through this very carefully. For example, I'm going to explain each and every component in this formula. So xi means every piece of data available to us. Xi minus x bar. X bar means mean of the data set. Mean or average of the data set is called x bar. And in this formula, we use xi minus x bar, the whole square, is a measure of how far the data deviates from the mean. And when we use the sign sigma I to 1 n, that actually means each and every data you find the difference is subtracted. Meaning the mean of the data is subtracted from each and every piece of data, and it's squared, and all of them are added together. Dividing by n gives the indication of so far, on average, data is from the mean. And the square root is used to correct the units. But there is one thing you need to remember. We use n when we are dealing with population. If we are dealing with a sample size, we use n minus 1. Okay? We are dealing with population. If we are dealing with population, we use n. If we are dealing with the sample size, we use n minus 1. That is the key factor you need to remember before understanding the formula for standard deviation. Okay? Now, please take a look at this and try to understand each and every component of the standard deviation. Now, I will do an example for you so that you understand how to deal with standard deviation. Can you please take a look? Now, consider this question. Calculate the standard deviation of the data set. Now here it is, nothing is mentioned. They haven't told us this is sample size or population, whatever. But here, when nothing is mentioned, we consider it as population. Now, let's copy paste our formula here. This is the formula. Okay. Now what I'm going to do first is going to create a column for data. Okay. So this is xi. It means each and every piece of data. So 2, 4, 5, 5, 6, 6, 7. Now I wrote this data in an ascending order. You don't have to do it. That's not an absolute necessary. I just wrote it down this way so that it is easier. Now the first thing I need is x bar, or mean of the data. To find the mean of this data, to do 2 plus, 5 plus, 4 plus, 6 plus, 7 plus, 5 plus 6, the whole divided by 1, 2, 3, 4, 5, 6, 7. Got it? I need to find the average or the mean of the data. So 2 plus 5, 7, 7 plus 4, 11, 17, 17 plus 12 is 29, plus 6 is 35, 35 divided by 7. So the mean is 1. So next thing I'm going to do is xi minus x bar. Or in other words, 2 minus 5. So I get -3, -1, 0, 0, 1, 1, and 2. All of you here? The next thing I'm going to do is xi minus x bar, the whole square. Xi minus x bar, the whole square. Okay? Is that clear to all of you? So 9, 1, 0, 0, 1, 1, 4. That makes this 16. So according to our formula, standard deviation of n pieces of data is square root of 16 square root of 16 over sorry, my mistake. Square root of 16 over the total number of data. Sorry guys, I divided it with mean. I misread the whole thing. Square root of 16 over n. So 16 over 7. This can also be written as 4 divided by square root of 7. So if you use a calculator, the approximate value is 1. That's what we get. This is how we calculate the standard deviation by hand. Okay? Now, there are shortcuts available in your calculator in order to find the standard deviation of a data set. I suggest you use those because you're allowed to use calculator in the exam. All the questions of the exam would be more complicated than this, so you need to learn how to use your calculator to calculate standard deviation. So I would suggest you take next 10 minutes to use your calculator and calculate the standard deviation without using the formula. Okay? Type in the model of your calculator in YouTube. Search for how to find standard deviation using, for example, Casio EFFX. EFFX, that was a standard model before FFX. So use your calculator, try and find how to use your calculator. Use a shortcut to find standard deviation using the calculator. Sorry, so using the calculator many times. Use your calculator to find the standard deviation, please. All right, now, if you have learned how to use your calculator, I would suggest you to use your calculator to estimate the standard deviation for this distribution of examination scores. So the range of the score and the frequency is given here. So please use this. Okay, so if you have learned how to use your calculator to find the standard deviation, let me show you some sample results that's displayed in the calculator. So if you use Casio FXCG20, this is the answer you will get. Or if you use T184, this is the answer you get. Now, what you need to remember is, even though the population standard deviation is always given by the calculator as X. This is the population standard deviation. And this is the sample standard deviation. Okay, keep these things in mind. So here we are not told this might be the scores for an entire grade. So that's the population. We will consider this as our answer, which is 16.81. So the standard deviation in this case is 16.81. Is that clear? I hope all of you are clear about this. So this is the standard deviation in this case is you consider population standard deviation. Now, let me show you a different scenario. How to compare the results of two classes including their spread. How to compare the standard deviation. Now, let me show you. Here there is no frequency involved. These are only scores of two different classes. And the number of students in these two different classes are different. So I would like you to give it a try. Use your calculator. Key in these data and see what happens. Please do it. Okay. So if you have considered this, so for set A, if you used your calculator, the Casio FX CG20, this is the answer you will get for set A. And for class B, set B, this is the answer. Yeah. So here are the interpretations for class A. Mean score is 78.47, and the standard deviation is 9.6263. Okay, and for class B, the mean is a lot higher than class A, which is 86.5, and the standard deviation is 8.92. So, what is the conclusion we draw? Even though class B average is better than class A because their mean is higher, it is not only that it's high, class B is a bit more consistent than class A. The standard deviation is a little bit less than class A. That means class B has a higher mean, which indicates that the students in class B generally performed better. And class A has a higher standard deviation than class B, indicating that the results in class A were more dispersed because it's more spread than the results in class B. Okay, so these are the conclusions we draw here. When you write these conclusions in the exam, you can say that the data in class A is spreads wider than the data of class B. The spread is more or more dispersed. The spelling is D-I-S-P-E-R-S-E-D. The data in class A is more dispersed than the data in class B. All right, so with this, I'm going to stop with standard deviation and move on to our next topic, which is normal distribution. Now, we already discussed normal distribution in class, but I would still like to show you what is normal distribution, what are the physical attributes of normal distribution, and how a normal distribution arises. So, to begin, please take a look. I will also show you the normal distribution table. Take a look. I hope all of you can see this very clearly. This is also called a bell-shaped distribution, which is symmetric about the mean. Now, one of the primary characteristic of normal distribution is that mean is equal to median is equal to mode. All the measures of central tendency right here. Mean, the median, and the mode are all right at the middle. Okay. Now, what this diagram means? What is the actual meaning of this diagram? That's what I'm going to tell you. For example, let's say that we found a height of 10,000 people. We found that the average height is 175 centimeters with a deviation of standard deviation (3 centimeters). Is that clear? The standard deviation of 3 centimeters in a population of 10,000 people. Let's say they are from a village or in an island, whatever. It's just to make you understand what does this diagram mean. So this is mu means mean, which is equal to 175 centimeter, and this means standard deviation, which is equal to 3 centimeters. That means 175 is here. From here to here, that says mu plus standard deviation. That means 175, this is 178. So this diagram, if the data has a normal distribution, what it means is 34.13% of people lies between 175 centimeter, 178 centimeter. It also means 34.13% of people lies between 175 minus 3, 172 centimeters. That's what this means. So this is mu plus 2 times standard deviation. This is 181, and this here is 184. This here is 169. This here is 166. Okay. So now my next question is, so in order to show this as a shortcut, I would write it as n, normal distribution, 175, 3 squared. This actually means there is a data with a normal distribution where the average of mu, this is the standard deviation squared. So you should consider that if 3 squared is given, that means you should consider it as the standard deviation is 3. This is the standard notation for expressing a normal distribution. This is how we express normal distribution. N bracket 175, 3 squared, that means n mean and the standard deviation squared. So from this, if there are 10,000 people, 34.13% is here. That means 3,413 people are between 175 and 178. 3,413 people are between this 1,359 people here, 1,359 people are here. So this 215 people are here. Again, 215 people are here. And below 166 is maybe 13 people. And above 184 centimeter is also. Okay. So this is the meaning of normal distribution curve or normal distribution table. You don't need to remember this table. This table will be given to you in the exam. And there will be questions that will be asking you about how to find the probability. For example, what is the probability of me choosing a random person out of this 10,000 people who's above 178 centimeter? So then you will have to add everything more than 178, like this part, 1,359 plus 215 plus 13 out of 10,000. So that's how we use this table in order to find probability of an event. So now let's go to a question and see how to deal with this. For example, okay, take a look at this question. Please read this question. The chest measurements of 18-year-old male footballers are normally distributed with a mean of 95 centimeter and a standard deviation of 8 centimeters. Find the percentage of footballers with chest measurements between 87 and 103, 103 and 111 centimeters. Please take a look at the question. Okay. All of you are done? All right. I assume that all of you are done here. All right. Shall we continue? All right, guys. So in order to do this question, you will need to refer to the normal distribution table or this table. So here they are telling us that the chest measurements of an 18-year-old footballers are normally distributed between a mean of 95 centimeter and a standard deviation of 8 centimeters. So that means n 95 8 squared. That's how I can explain this. Like this is a normal distribution with a mean of 95 and a standard deviation of 8. I'm saying this, I'm showing you this again and again so that you understand how normal distribution is expressed in statistics. So the next part is find the percentage of footballers chest measurements between 87 centimeter and 103 centimeters. So this here is 95. This here is 103. This here is 111. This here is 190. This here is 87. This here is 79. This here is 71. Clear? So between 87 and 103 centimeters, find the percentage. So the answer to AI is 34.13 plus 34.13, so 68.26% of footballers have chest measurements up to 87, from 87 centimeters all the way to 103 centimeters. So the second part is from 103 to 111. So that is 13.59%. Now find the probability that the chest measurement of a randomly chosen footballer is between 87 and 111. Then we need to add these. So the answer to this is 81.5 0.85%. So approximately 82% of the footballers have a chest measurement from 87 to 111 centimeters. That's what the question means. Okay. Now I will give you, these are questions that are already in your worksheet. So please take a look at this question. Please take a look at this question and try and do it, please. So the first part means 16, it's a normal distribution. X is the data with normal distribution, 16 mean, and 3 as standard deviation. Okay, so if I bring the table in here, this is the table. So this here is 16, this is 19, 22, 25, this here is 13, 10, 7. This can be any type of data, doesn't matter what it is. So the question is, what is the probability of finding something randomly chosen data from this data set? Is between 13 and 16. So 16 is here, 13 is here. So the probability of the chosen data between 13 and 16 is 34.13%. So you understood? I hope you understood the concept. If you understood the concept, please try and do B and C. Those who couldn't do at the beginning, please try it now. Okay. So now you can say that the probability of the data less than, the chosen data less than or equal to 13 is from here to here. So that makes it 2.28 plus 13.59. So 15.87%. I just added all these probabilities together. Okay. Now, the last part. What is the probability of a chosen piece of data greater than or equal to 22? So greater than or equal to 22 means towards this side. Again, 2.15 plus 0.13 is 2.28%. All right, guys. So this is the last part of normal distribution that we will discuss. Now we have one more topic, which is correlation. Now, correlation is a more elaborate topic. I already gave you the necessary notes and stuff in class. So I'm going to repeat it once again. So in two variable statistics, correlation refers to the relationship or association between two variables. Correlation refers to the relationship or association between two variables. One of the most important part of correlation is direction. And that's given here. This here is called and generally upward trend. And this trend is positive. And the gradient is positive. The trend is positive. The gradient is negative. The trend is negative. And when there is no correlation, we cannot predict a positive or negative trend. So it doesn't matter. So this is the first characteristic of a correlation, that is direction. Then we come to the strength of the correlation. So when the points are clustered around the imaginary line. So like, let me make it very clear for you. We don't draw this line when we are plotting the points. This is an imaginary line, or what we call it, a line that best fits the eye, and how you see it. When the line is really clustered together, we call it a strong positive. And when there is a negative trend, we call it a strong negative. This one here is a moderate positive, and the dots are a little more spread than the other one. And here it is a moderate negative. Again, the trend is when the gradient of the line that best fits the eye is negative. We call the trend is negative. Or there's a negative correlation, a moderate negative correlation. Now, this is what we call as a weak correlation. This is a weak negative. This is a weak, first one is a weak positive. So this is the second characteristic. The first one is direction. The second one is strength. There is another one, which is the linearity of the correlation. We call it, sometimes the line can be almost straight. So that's when we call it linear. Sometimes it doesn't follow a linear trend. So we don't call it a curvical correlation or anything. We just say it doesn't follow a linear trend. The points, the correlation doesn't follow a linear trend. That is the explanation for it. Now, there are situations, for example, let me show you an example of the correlation. Just for your understanding, this is a weak positive. This is a strong negative. This here is no correlation. This is a moderate positive. This is a strong negative. And this here is also a moderate positive. This doesn't move in a straight line, so I can call it not linear. Okay, this is so now these are all pictorial understanding. You're trying to predict the correlation or trying to understand correlation using pictures or diagrams. Here we will also learn how to calculate the Pearson's correlation coefficient. Using formula. Again, you don't need to learn the formula. Formula will be given in the exam. And also, there are shortcuts available in your calculator. Use the formula. What you need to understand about R is a sign of R. Correlation is always a value between -1 and +1. Correlation is always the value between -1 and +1. Negative means it's a negative correlation. Positive means it's a positive correlation. The size of R indicates the strength of the correlation. The size of R. You should always remember the size of R. If R is closer to 1, or -1 or +1, it indicates a strong correlation. If R is closer to 0, it indicates no correlation. For example, 0.5 is a weak, moderate correlation. Anything less than 0.4, 0.3 is a very, very weak correlation. So, if you have completed the worksheets I gave you, then with this review video, I think you will be fine. You should have a very strong understanding of correlation, normal distribution, and standard deviation by now. All the best for the exam. See you later, guys. Okay, so we have already discussed standard deviation. We have already discussed normal distribution. We have already discussed Pearson correlation coefficient. One thing I need to remind you is learn the shortcuts for your particular calculator. You can use YouTube, type in your calculator model. It will tell you how to find various statistical values. So use that, because otherwise it's going to take a very long time for you to do the calculations. Okay, see you guys. Have a good day.